Our mission is to review properties of exponents. So what you're going to take some time to do right now, I'm recording you guys, by the way. What you're going to take some time to do is review kind of what we did yesterday with some exponents tossed in. So this is your warm-up. You're supposed to substitute in a value of a equals 3 and b equals 4. While you work on this warm-up, this is kind of our routine. I'm going to walk around and start checking off the homework assignment. If you're a person who finishes the warm-up lightning quick, the next thing you're going to do is you're going to start on this exploration. And you could work on this exploration with a partner. We're going to talk about it together as a group. Yeah, we're on P2. The independent practice, is that what you were just looking at? Yeah, we're going to do that as part of our review for the test. So yeah, you do have a couple of blanks still in P1, but we'll take care of that for you, all right? All right, any questions about what you're working on right now? I'm going to start checking some homework and we'll reunite as a whole group in just a minute. Okay, so there are the answers to your warm-up. At this point in time, you want to maybe take a break from working on that exploration. Just give yourself a minute to check over your warm-up answers. You'll see that I always circle my final answer. That makes it real easy to check quickly. So right now, you're going to take a few minutes to go ahead and go over your warm-up. If you were watching this at home, by the way, like because I sometimes flip from slide to slide rather quickly, you could just press pause on your browser. If you just hit your space bar too, that pauses the video real quick. So if you were at home watching this or in the library watching this or wherever, just hit your space bar and it'll stop, and then you could take a little extra time with it if you needed to. Okay, there are questions about that? Okay, so now you're working on your exploration. Real quick, take care of this for you. So as I walk around the room, you folks were doing a pretty good job with this. The purpose of today's lesson, again, is to review our properties of exponents. Basically, we're going to finish this exploration, fill in the chart on page 14, and that's probably going to take us to the end of the lesson. Wrap it up here. So for number 1, as I walked around the room, most of you know that 2 times 2 times 2 times 2 times 2 is 2 to the 5th. Likewise for part B there, we have x times x times x times x times x times x times x. That's x to the 7th. For part C, you get x to the 5th, and D was x to the 4th. Remember, don't write it down unless you understand it. So if you can't remember that, if you have 7x, let's say, for part B, which I didn't see anywhere, you might want to ask. So what we have right now within the context of these properties of exponents are really just shortcuts. True story. You could do each and every single one of your homework problems a long way, or you could use these properties to make your life a little easier. So for number 2, if you take a look at it, you have x to the 7th times x to the 4th. So if you have x to the 7th, we said that that's x times x times x times x, 7 times. X to the 4th would just be x times x times x times x. And then we're multiplying those two things together. Well, based on the property that we talked about in class yesterday, known as the associative property for multiplication, you could regroup these parentheses however you want. But what's going to remain the same is the fact that you're taking a product of 11 x's multiplied together. No matter what you do with the parentheses, you're still multiplying 11 x's together. So what we actually end up getting for our answer there is x to the 11th. Same thing with number 3. If you have x to the 5th times x to the 2nd, you could see that you have 5 x's and then 2 x's, and you could use that associative property of multiplication and put those parentheses really anywhere you want. But what's not going to change about the problem is that you're taking the product of 7 x's. So you actually get x to the 7th as your answer. So moral of the story, what do you do when you multiply like bases? What are you supposed to do with your exponents? You should add them. So make sure you have that response recorded down in your notes. I do see quite a few of you had it in even more detail than I did, but basically we just add the exponents together. So you had to practice this rule on your own. If you have a to the 8th times a to the 5th, that's the same thing as taking a to the 8 plus 5. It's a little shorter to do it that way. You get a to the 13th. Okay, there any questions on the first part of the exploration? So when in doubt, you could do these problems the long way and write out a times a times a times a times a over and over again, but really it's so much easier just to use the properties as shortcuts. We have this a very similar rule for division. What happens when you divide like bases? You know, Christopher. You do, excellent. So here's what he's talking about. I had to review this with my other class, a little bit of scratch work off to the side here. You know, a over a is kind of like 7 over 7. Really, it's just 1. So when I teach this, it's kind of like your numerator does battle with your denominator, if you will. And they like duke it out over that fraction line. The fraction line is actually your battle line, if you want to say. So if you're looking at a to the 5th over a to the 3rd, these a's do battle with each other. So this guy takes out this guy because a over a is 1. And this guy takes out this guy because, well, hey, a over a is 1. And then this guy takes out this guy because, well, one last time for kicks, a over a is 1. So what you're doing is 1 times 1 times 1 times a times a. You're left with a times a on the top, which is a squared. So a to the 5th over a to the 3rd is a squared. For part B, I had them do battle. This time around, the a squared was left on the bottom. If we did the subtraction, it would actually be a to the negative 2nd. But you might recall from your Algebra 2 class, you can't leave me negative exponents in your answer. That's not a Mrs. Lucas rule. That's like a real rule for life. So you can't leave me negative exponents. You want to practice with that on your homework tonight. For part C, all the a's cancel off. It's not like you get 0. You have a to the 3rd over a to the 3rd. Really what you're ending up with is a to the power of nothing. And what we're going to learn today is something called the 0 exponent rule, which just means that anything raised to the power of 0 is 1. It's because everything's going to reduce out. These all make 1s hanging out there in the problem. So Christopher said it, nailed it. Number 7. What do you do if you have like bases? In a quotient with each other, you subtract the exponents. So for part 8, we could use this rule. X to the 7th over x squared is the same as x to the 7 minus 2. That is x to the 5th. If you reverse it, you do x to the 2 minus 7. That's x to the negative 5th. But you can't ever leave me a negative exponent. So we use something called the negative exponent rule. It's on the next page. That's going to be 1 over x to the 5th. Do you remember these? Yeah. Oh, awesome. Lots of nods. Okay, so to summarize all of these properties that I just talked about, we have a little chart. I just grabbed these examples from page 14 in your book. I put it up there in your notes. They're filled in up here. So yeah, let's talk about these. And this will bring us to the end of our lesson today. Negative exponent rule. I feel like this is a lot of information, so I'm going to screen shade. I feel like your little eyes are like searching the screen. Okay, so number 1 is the negative exponent rule. I call this one the upstairs downstairs rule. The example that we have here is y to the negative 4th. And for fun, I put it over 1. Y to the negative 4th is in the numerator. If I want to make that 4 positive, I have to move it to the denominator. So y to the 4th moves to the bottom. You might recall you can't have a topless fraction. That's completely inappropriate. You have to put a 1 on top as a placeholder. Thanks for laughing. It was supposed to be a joke. So yeah, no topless fractions. Number 2, 0 exponent rule. We talked about that on the previous page. Anything raised to the power of 0 is 1. Remember when we had a to the 3rd over a to the 3rd and that cooked down to be a to the nothing? Well, it's because everything reduced out and they turn into 1s. So a to the power of nothing is 1. My example? Even if you have like some crazy stuff going on in your parentheses. I said x squared plus 1, put it in parentheses, and then raise it to the power of 0. That is all just equal to 1. Next one. Remember, don't write it down unless you understand it. That's our rule. So we have a to the m times a to the nth equals a to the m plus n. That's the addition rule, so to speak. Our example, if you have 3 squared times 3 to the 4th, that is equal to 3 to the 6th. 729. Power of a power rule. I'm going to show you both of these rules at the same time, actually. My colleagues probably don't like that I teach it this way, but I do. We kind of have the distributive property for exponents. That's true. I always just give it 2 exclusions. You're not allowed to distribute an exponent into parentheses if certain symbols are in those parentheses. Does anybody remember? Like sometimes you just have to FOIL. You know, you can't distribute the exponent in. If there's a plus or a minus, you are not allowed to use these properties. If there's a plus or a minus, you can't just go distributing that exponent in. So for instance, I have y to the 3rd, all raised to the negative 4th power. I'm allowed to multiply 3 times negative 4 to give me negative 12. But then, boo, I have a negative exponent. So I have to use my upstairs downstairs rule or my negative exponent rule to move y to the 12th downstairs. Can't have a topless fraction, so I put a 1 up there. Number 5, you could distribute that 3 to the parentheses as long as there's no plus or minus. I don't see a plus or minus in there, do you? I see a 5 and an x. So distribute away. I got 5 to the 3rd and x to the 3rd. Don't forget to distribute it to that 5 right there. That's a real common mistake. It's 125x cubed. Quotient of powers rule is our subtraction rule. I went simple on this one. X to the 7th over x to the 4th. You just do 7 minus 4. You get x to the 3rd. And our last rule of the day, power of a quotient rule. Power of a quotient rule. You're allowed to distribute that exponent into the parentheses as long as there's no plus or minus. So you can distribute that 3 in, you get 2 to the 3rd over x to the 3rd, that's 8 over x cubed as your final answer. You have problems like this on your homework assignment for tonight. I went tricky when I was picking problems out. I did. I went there. There's some on there that might be a little bit tough for you. But I'll go ahead and let you know that we're going to spend not just today, but 2 more days on this topic. So if you didn't have a good time on the homework assignment, which is on your agenda, by the way, come with questions on Tuesday and have a nice weekend. Enjoy.